revisiting irrational number. So irrational numbers are the numbers which cannot be written in the form of P divided by Q, right, where P and Q are co-prime and Q is not equal to 0. So all of these words you need to understand. The word co-prime, right, then irrational number itself. So all of these words, it has to be clear, and you can learn this in your math basics. So let's start off pre-requirement. If a square is divisible by p, then a is also divisible by p. This is one thing which we need to know before we start off taking up irrational number questions. The second thing which you need to know is proof by contradiction. Two things. So the second one is weird and nice. The first one is a bit weird, but not too weird. So the theorem states like this, and again, here I have written, it need not be memorized, it just has to be understood. So the theorem goes like this. If P is a prime number, so P is a prime number. If P divides a square, then P divides a, where a is in positive integer. As usual, let's understand what is that written over there, rather than just doing the proof. See, 196 is nothing but 14 square, and 196 is divisible by 7. So let's have a look. 196 divisible by 7. Yes, it's divisible, right? So now, so if 196 is divisible by 7, which is nothing but 14 square divided by 7, if this is divisible, that is giving me an integer, then as per the theorem, 14 also is divisible by 7. Make sense? See, the point is 196 is made up of, in its prime factor form, 196 in its number and prime factor. So in its prime factor form, 196 will be 2 square into 7 square, and 14 will be 2 into 7. So by default, 7 will be one of the prime numbers. Only then it can divide, right? If not, it won't be able to divide. 7 has to be a part of both these numbers, because 196 is a square of some number, and 196 itself is divisible by 7. So that 7 has to come from this number, is it not? So if 196 is divisible by 7, 14 also by default will be divisible by 7. Why is this important? It's part of your proof, root 2 being irrational, so on and so forth. So there is a proof wherein there are a set of questions wherein we are trying to prove that, okay, given this given number is irrational. So for that we need to learn this. Okay. So now one more example. So here I have written 676, which is 26 square. 676 is divisible by 13. 676 is divisible by 13. So 26 square is divisible by 13. This implies 26 is divisible by 13. Again, quite simple. Number in its prime factor form. So we have 676, which can be written as 2 square into 13 square, right? And 26 can be written as 2 into 13. Make sense? It has to be, na? There's no other way. Because 676 is square of 26. So it has to be square of the prime numbers, what 26 is made up of. So in general, if a square is product of a, obviously it's product of a and a, it's a, if a square is divisible by p, if a square is divisible by p, this implies a is also divisible by p, with our result being an integer, provided p is a prime number. Remember, p is a prime number. That condition also, it's important. It has to be a prime number. Okay, so this was your first theorem. Very simple. If a square of a number is divisible by some prime number, the non-square version of it has to be divisible by that prime number. Straight and forward, simple.